Basically, you're talking about this SV40, which both Health Canada and the FDA was not told was in the vaccine, actually binds to cells within our body that help us fight cancer. So it actually, as far as our immune system goes, basically makes it more difficult for us to fight cancer.
It binds to a gene known as P53, not necessarily a cell line, but in all of your cells, there's a tumor suppressor gene known as P53. It gets activated when there's DNA damage. And now we don't know what this is doing when it binds to P53. Okay, we know that we have papers showing that it's binding, but anything that binds to that gene and you have billions of copies of it as a contaminant should be a major red flag. Now, there's additional information out there that Wafik El-Diari has published that demonstrates the spike protein actually also deactivates P53's translation. So in addition to this SV40 promoter being in there that interferes with P53 in some way, he has demonstrated that the spike protein itself can downregulate this. So we've got two things now that are attacking the tumor suppressor gene that are inside these vaccines. Moderna obviously has spike. They don't have SV40. Pfizer has both. So there may be, maybe there's an argument for there being more cancer risk with Pfizer than Moderna. Okay, so I do want to touch on what do we have for guidelines about DNA contamination and where do they come from? All right, so most of this DNA contamination was derived from regulatory architecture that was trying to address people growing vaccines in eggs or in other cell cultures where there could be some genomic DNA that comes through. And back before the NCBIA Act, which is this is a Vaccine Injury Act here in the United States, the limit was 1,000 times lower than it is today. Once that act went into place, the pharmaceutical industry has bumped up this regulation 1,000-fold, and now it's up at 10 nanograms of DNA that's allowable. These were all based on naked DNA getting into an injection. Now, naked DNA in an injection has about a 10-minute half-life. When you put a lipid nanoparticle on it, that DNA gets trafficked right to the cell, just like the vaccine mRNA, and we don't know its half-life. There could be a persistence problem here, and this could be explaining why people are seeing spike-based nucleic acid in patients 30 days out in plasma. We've seen them. I'll touch on that a little bit later. There's several different papers that touch on the persistence problem. The other thing to keep in mind is that 10 nanograms of genomic DNA is only about 1,000 copies of the human genome. But if it's 200 bases and it's broken up into small pieces, we're talking about 50 billion copies.